Let's take a look at some of the other properties of logarithms. Some of the reasons why logarithms, when dealing with real-world problems, are, I guess, the way that the logarithm can be manipulated or changed. Okay? One of the rules we can use is called the product rule. And what the product rule for logarithms says is if you take the logarithm, it can be the log or the natural log, because remember, natural log is just log base e. So if you take the logarithm of a product, that's something times something else, then you can rewrite that as log base b of the first factor plus log base b of the second factor. So what does that actually mean? That means if I have the natural log of 7x, you can write that as the natural log of 7 plus the natural log of x, because I have a product here between two numbers, so I can break them up like that. Now it works both ways. If you have a sum of two logarithms and there's a plus between the two logarithms, then you can write it as a product. Okay? So, for example, if I have log base 7 of 8 plus log base 7 of x, I'm even going to go another step further, plus log base 7 of y. Anytime you have a plus between two logarithms, as long as their base is the same, you can multiply what you're evaluating the logarithms at. And it doesn't just work for two, it works for two terms, but it'll work for more terms. Every one that has a plus in front of it, you can multiply all these things and write them as one logarithm. So this is log base 7 of 8 times x times y. So as long as the logarithm is positive, as long as there's a plus in front or it's positive, and you have the same base, you can write them as a product. If you have a product, you can write them as a sum. Alright, so you try this one. I want you to write this using the product rule. Log 10x. Notice that I didn't write what on this problem. I didn't write the base. When you don't write the base with a logarithm, it's understood to be a 10. Okay, so I'm going to write the base in there, but just know if you're working a problem and there's no base, it's understood to be a 10. So I can rewrite this as log base 10 of 10 plus log base 10 of x. Now, can I simplify log base 10 of 10? What is the power here? If it's not written, it's understood to be a 1. That's right. So, if this base and this base match up, the answer is 1. So this is 1 plus log base 10 of x. Okay? Alright, let's try one more. What if I have log of 100x? So first write this as log of 100 plus log of x. Now remember, again, the base is 10 if it's not written. So if you want to write it in there, that's fine. Now, is there any way to change 100 into 10 to some power? Of course there is. 100 is 10 to what power? The second power. Right? So log base 10 of 10 to the second power is 2. So I have 2 plus log base 10 of x. Alright. That is the product rule. You take a product that you are evaluating at a logarithm and you make it into a sum. The next rule we're going to look at is called the quotient rule. This is the quotient rule for logarithms. Quotient means divide. You should also, when you hear the word quotient, you should think fraction, because quotient and fraction are the same. Alright, the quotient rule for logarithms says that if you have the log of a quotient or a fraction, a term over another term, that's equal to the logarithm evaluated at the top term, or the numerator, minus the logarithm evaluated at the bottom term, or denominator. So log base b of a over b is equal to log base b of a minus log base b of capital B. It also works in reverse. If you ever have one logarithm minus another logarithm and they're the same base, then you can make a quotient out of that. Okay? So let's say that I had log base 6 of 13 over x. Then I could rewrite that as log base 6 of 13 minus log base 6 of x. Now I can't simplify log base 6 of 13 because I can't change 13 into 6 to some power. So I would have to leave my answer like that. Alright. Let's say I had log base 2 of 16 over z. Alright, that would be equal to log base 2 of 16 minus log base 2 of z. Alright, now let's look back at the first logarithm, log base 2 of 16. Can we change 16 into 2 to some power? 2 to the 4th power is the same as 16. 2 times 2 times 2 times 2 is 16. So since I can change that term, I have the same base now. The answer for the first logarithm is 4. So I have 4 minus log base 2 of z. I leave my answer like that. Alright, what if I had the natural log of e to the 4th over 3? I could write that as the natural log of e to the 4th minus the natural log of 3. Alright, so remember natural log is log base e. So this is log base e of e to the 4th. So that first term simplifies to just 4. So I have 4 minus natural log of 3. Now you have to leave, natural log of 3 is a constant. It's an actual number. If I punch that in my calculator, I get natural log of 3 is 1.0986, so on and so forth. So, but leaving it like this would be the most correct answer. This is in exact form. Okay. So you try this one. The natural log of e to the 5th over 11. So I can write this as the natural log of e to the 5th minus the natural log of 11. And then the natural log of e to the 5th is 5. So 5 minus natural log of 11. The easiest property, I would say, for logarithms is a property called the power rule. The power rule is probably the easiest property to understand. Mathematically, it's probably the most powerful property. No pun intended, even though it's called the power rule. The reason, what makes it so powerful is it says if you take the log of something raised to a power, so I'm going to make this the p power, just any power, you can take this power, if you're taking the logarithm, if you're evaluating the logarithm, you can take the power and move it to the front. So log base b of m to the p power is the same thing as p times log base b of m. So being able to take a power and move it is a very big deal. So, for example, let's say I had the natural log of x to the 3rd power. I can rewrite that moving the 3 in the front, I can rewrite that as 3 times the natural log of x. Alright, what if I had this? The natural log of the 5th root of x. Remember, the 5th root means that would be x to the 1/5 power. Now, I can apply the power rule and take this and move it in front. So that's 1/5 times the natural log of x. The power rule, just like those other rules, works both ways. If I had 4 times log base 3 of x plus 1, if I wanted to, I could apply the power rule backwards. I could move this 4 up here. So that's the same thing as log base 3 of x plus 1 raised to the 4th power. So I can use the power rule both ways. So that is the product rule, the quotient rule, and the power rule for logarithms. Alright, and that's where, so to expand logarithmic expressions, we want to apply the 3 properties. We want to apply the power rule, the quotient rule, and the product rule. So think about when something expands, it gets larger, right? Well, that's what we're doing. We're making something larger. Alright. So let's say that I had log base 5 of the square root of x over 25y squared. And I wanted to expand this logarithm. The first property that you want to apply is the quotient rule, if you can. If you have a fraction or a quotient, you want to apply the quotient rule. And so that would be log base 5 of the square root of x minus log base 5 of 25y squared. So the top over the bottom. Log base 5 of the numerator minus log base 5 of the denominator. Alright, the next thing you want to do, if you can, is apply the product rule. Now I cannot apply the product rule with this. I can rewrite the square root of x as x to the 1/2 power, so that after I get through applying the product rule, the last thing I'll do is apply the power rule. Alright, now notice there's a minus right here. So anything that I do after this minus sign, I need to subtract it. Alright. So I'll put everything that I'm about to do in parentheses, and then I'll distribute the negative. This is log base 5 of 25y squared. So you can rewrite that as log base 5 of 25 plus log base 5 of y squared. And so now I need to subtract both of those. So I have log base 5 x to the 1/2 minus log base 5. Is there any way to rewrite 25 as 5 to some power? Yes, right? That's the same thing as 5 squared. And then this negative I have to distribute to both terms, so that's minus log base 5 of y squared. Alright. Now this logarithm right here is going to simplify, right? Because you have the same base here and here, so the answer is the power. Before I write that down, though, the last step when expanding is to apply the power rule. Alright. So if I take this 1/2 and move it to the front, that'll be 1/2 log base 5 of x. And then log base 5 of 5 squared is what? 2. So say minus 2. And then I can take this 2 and move it to the front. So that's minus 2 log base 5 of y. So that logarithm is completely expanded. Okay? And you can see sometimes expanding logarithms allows us to simplify one of the terms, and it did. We were able to take the log of base 5 of 25. And so that's usually the order that you go in. Usually you try to first apply the quotient rule, then apply the product rule, then apply the power rule, and that's when expanding. Now I can think of a time when we would want to apply the power rule first. Let's say that I had log base 3 of the square root of x over 3. So there's not really much that I can do. Like, I can't apply the quotient rule because it's under this radical. The fraction is under the radical, so it's kind of like the radical is holding my problem hostage. It's stopping me from doing anything. But remember, if it's a radical, you can think about it like it's to the 1/2 power. And so if I want to expand this logarithm, I need to take this 1/2 and move it in front. Alright, and now that I've moved that power, I can apply the quotient rule. The only thing is, whatever I do after this 1/2, since it's in front, I have to multiply it times everything. So it's going to be 1/2 times, so that'll be log base 3 of x minus log base 3 of 3. And then what's log base 3 of 3? What's the power? So it's just minus 1. Alright, and so I have 1/2 log base 3 of x minus 1/2. Alright, I want you to try to expand these two problems. Alright, expand log base b of x to the 4th times the cube root of y and log base 6 of the square root of x over 36y cubed. Take a minute and expand those two logarithms completely. So the first thing I would do, see if you can apply the quotient rule. You can't on this first problem. So I would try the product rule, which you can, because we have a product here. Now I do have the cube root of y, so that's the same thing as y to the 1/3. Now that I've applied the product rule, I need to see if I can apply the power rule, and I can. So it's 4 log base b of x plus 1/3 log base b of y. All right. Now I need to first see, can I apply the quotient rule? I can, because there's a fraction. This is log base 6 of the square root of x, which is x to the 1/2, minus log base 6 of 36y to the 3rd. Now I am subtracting here, so anything that I do after this subtraction, I need to make sure that I subtract it. Okay, so that's log base 6 of x to the 1/2 minus, I can apply the product rule, but again it's after this minus sign, so I'm going to just put all this in parentheses. Log base 6 of 36, and you can write 36 as 6 squared so that you can actually evaluate that, plus log base 6 of y cubed. Alright, so that's log base 6 of x to the 1/2, and then minus log base 6 of 6 squared is just 2, right? And then this minus here has to go with that too. It's minus log base 6 of y to the 3rd. Now the last rule I would apply is the power rule. So this is 1/2 log base 6 of x minus 2 minus log base 6, 3 times log base 6 of y. All right, let's take a look now at condensing logarithmic expressions. Think about what condensing means. When I hear the word condensing, I always think about condensed milk. I don't know why, but I do. But condensing means to make it smaller. So what if we have a logarithm that's written out, expanded? How could we make that just one logarithm? And so expanding and condensing logarithms do have their place in math. Expanding logarithms that we just covered, it has its place in simplifying and something that looks real tough, like a big fraction, and changing it into a bunch of little terms. Maybe so that we can do something with those little terms. Condensing logarithms, if you have a bunch of logarithms, sometimes putting all those logarithms together, condensing them, will allow you to solve an equation by condensing and then changing it over to exponential form. So they do have their places in in algebra where you can use these to solve equations and solve for x and do stuff like that. So it's important that we can condense logarithms as well. So let's say that I had, let's say I had 2 times log of 4x plus 5 minus log of x. Alright, so it's almost like we want to go through the opposite progression with what do we do first. With expanding logarithms, the last thing we do usually, not all the time, but most of the time, is the power rule. Well, the first thing that we do when we condense logarithms is if you have a number in front of a logarithm, then you need to move it up and make it a power. So I'm going to take this up and move it up there and make it the power. So I have log of 4x plus 5 squared minus log of x. Alright, now after you do that, here's what I do. If you can't apply the power rule anymore, now look at all the logarithms. It doesn't matter how many you have. You can have 2 or you can have 10. As long as the base of all the logarithms are the same, and these will be log base 10 since there's nothing written there, as long as they're all the same, if it's a positive logarithm, meaning it doesn't have a minus in front of it, then whatever term you're evaluating, that's going to go in the numerator of our fraction. If it has a minus in front of it, that would make it a negative logarithm. Then whatever you're taking the logarithm of will go in the denominator of your fraction. Okay? So like I said, it doesn't matter. We just have 2 terms here, but I could have 10 terms out here. I would take a product of all and make a big fraction, and all the ones that were positive, I'd take a product of all of what I was evaluating and put all those in the numerator. And then all the ones I'm subtracting, I'd gather all those together and make a product in the denominator of the fraction I'm about to make. Okay? So this would equal log of 4x plus 5 squared over x. Alright, I put another parentheses out here on the outside of everything. Alright, let me do another one. Let's say that I had 1/2 log of x plus 4 plus 4 log of x minus 3 log of y squared minus log of z. Now, it really wasn't good for me to write 3 log of y squared because that was already squared, so I'm going to take the squared off. So if you will, just erase that square. In the third term, erase that square there. Alright, so the first thing that I want to do is apply the power rule everywhere that I can. So, power rule. Now, right here, make sure you put that with the x. It's not over here with this stuff here. So 4, move it there. 3, move it there. So I have log of x plus 4 to the 1/2 plus log of x to the 4th minus log of y cubed minus log of z. Alright. Alright, now that I've applied the power rule everywhere, I want to take all of my positive logarithms. I'm going to make one logarithm and a fraction. And all of my positive logarithms, I'm going to take those and I'm going to make that a product in the numerator. So this is x plus 4 to the 1/2 times x to the 4th. And you can write the x to the 4th in the front or first in the numerator if you want to. It doesn't matter. Those are the two positive ones. I have two negative ones as well. So that's going to be y cubed and times z in the denominator. Alright, so if it's a positive logarithm, all of those terms go in the numerator. If it's a negative logarithm, all of those terms go in the denominator. And you make sure that you make a product of all those terms. That means multiply all those terms as you put them in, either the numerator or the denominator. Alright, I want you to try this one. Alright. 1/4 log base b of x minus 2 plus log base b of 5 minus 10 log base b of y. So take a second and condense that logarithm. Okay, so the first thing that I would do is I would apply the power rule anywhere I can, the power rule backwards. So this is going to be log base b of x minus 2 to the 1/4. Alright, then I have plus log base b of 5 minus, now I can move this 10 there, so that's going to be log base b of y to the 10th. Now, I want to make one logarithm. Alright, and I'm going to make a fraction because I do have some positive and negative logarithms here. All of the positive ones, I'm going to put all of those values in the numerator. So I have two. I have this one here, and I have this one here. I'm going to write the 5 first, just because that's usually what we do. Usually, if we have a constant, we write it first. So 5 times x minus 2 to the 1/4. And then I only have one negative logarithm, this one here, so that's y to the 10th. Alright, so that is expanding and condensing logarithms.